Companies calculate their equity or financial worth by subtracting their liabilities from their assets. The graph shows the Good Food Company's assets and liabilities during its first fiscal year. Generate tables of values and equations to represent A of x, the asset function, and L of x, the liability function for x months. Generate Q of x, the equity function. Compare the representations. Okay, so let's just look at this graph here. So we know that the equity of this company will equal their assets, A of x, minus L of x, their liabilities. So let's go ahead and figure out some of these values, put them in a table. We'll graph it and we'll find the equations. So with our table here, we see for A of x, it's a parabola here. So, and our first point is at 0, 0. And then we have 2, 1,000, just looking at the points they give us. And then so on. I'm just going to fill in the rest here. And then with L of x, then the y-intercept starts at 0, 200. And then at 2, it goes to 400, 4, 600, 6, 800, and 8, 1,000. So just filling those in. And then Q of x is just A of x minus L of x. So 0 minus 200 is negative 200. 1,000 minus 400 is 600. And so on, we get the rest of the values. Okay, so now that we have our Q of x values, let's go ahead and plot those in our graph. So 0, negative 200, and then 2, 600, 4,000, 6, 1,000, and 8, 600. So, connecting these, and I'm assuming it doesn't just go straight across in a line. If we were to look at 5 for a minute, and if we look at the values there, that looks about 1750 minus 700. Well, that's about 1,050 right there. So, so that would make sense that this looks like it's going to be a parabola and curving there. Okay, so we have our new graph there, and it appears that they started out in debt, with their value when they started the business. They started doing really well. Their equity went up, meaning that they had a lot more assets than liabilities here by 5 months, and then their business started declining again until looks around 9.5 months that they went back into debt. So meaning that they owed more than they have. So let's go ahead and look at the equations also. Okay, so in order to find the equations for these, we'll find the finite differences for A of x and L of x. And to do that, we actually need to, depending on the type of equations these are, so we can tell that L of x, it looks like it's going to be linear. So it won't really matter what our delta x is there. But for A of x, since this is a quadratic, the only way that we can find our actual equation with the formulas that we have from chapter 1 is by having delta x equals 1. So this table skips, and we have a delta x of 2 because we go every 2. So I'm just going to point out the ones that we missed so that in our next table, we're going to add in just every single one. So at 1, looks like we have 550. At 3, 1350. And at 5, 1750. Okay, so that's going to help us out, and then we'll still have the 2, 4, and 6 values. So, so in our A of x, I just went ahead and put some of these values, but I added in, you see, 1 and 3. And then for L of x, I just had the same ones that we found before. So let's go ahead and find the finite differences here. So 1,000 minus 800 is 200. 800 minus 600 is 200. And so on. These each subtract to 200, and we see that it is linear, same as what we saw in the graph, because the first difference is constant, and then delta x here is 2, because 8 minus 6 is 2, 6 minus 4 is 2, and so on. Each one equals 2. And so then to get our equation, we know that's y equals mx plus b, so m will be equal to delta y divided by delta x. Delta y in this case is 200, and delta x is 2, so m will equal 200 divided by 2, which is 100. And then B will just be our y-intercept. So we see our y-intercept is at 0, 200. So then B will just be 200. So our final answer for L of x will be 100x plus 200. And then to find A of x, then let's go ahead and find the finite differences. So 1600 minus 1350, we get 250. 1350 minus 1000 is 350. 1000 minus 550 is 450. And 550 minus 0 is 550. And so subtracting those, 250 minus 350 is negative 100. And negative 100 again for 350 minus 450, and again negative 100. So we see that's going to be quadratic, as we predicted on our graph. And so let's go ahead and again, this is delta x of 1, 4 minus 3 is 1, and so on. And that was important because the formulas that we used from chapter 1 need delta x to be 1. So here's our formulas from chapter 1. So a plus b equals the first difference. And then 2a, let's go ahead and do these other two first. That'll be a little easier. So c is the y-intercept, and we see here our y-intercept is 0, 0. So we know c equals 0. And then 2a equals the second difference, which is negative 100. And so if we divide by 2 on each side to solve for a, then a equals negative 50. And then for b, then a plus b equals the first difference between x equals 0 and x equals 1. So first difference between x equals 0 and x equals 1 is 550. And then we know that a is negative 50. And so to solve for b, we can add 50 to each side. And we see that b equals 600. And so to put our equation together, then we get a of x equals negative 50 x squared plus 600x, and then c is just 0, so we don't need to put it on the end. And so there's our two equations, and so to generate q of x, we need to subtract those. So I'm going to mark this up, do this in a different color, and find q of x, which we know is the assets a of x minus the liabilities L of x. So a of x is negative 50x squared plus 600x minus L of x, making sure to put that all in parentheses, is 100x plus 200. So simplifying this out, then we get negative 50x squared plus 600x, and then minus 100x, just distributing the minus, and then minus 200. So then we can add any like terms here. So positive 600x minus 100x is 500x, and nothing else can be combined. So we have negative 50x squared plus 500x minus 200. And we can go ahead and, now that we've found the equation and the graph and the tables, we can go ahead and summarize our answer. So here's our table, the full table actually going from 0 through 6, and also using the patterns and the finite differences in the table. A of x equals negative 50x squared plus 600x, L of x equals 100x plus 200, and Q of x equals A of x minus L of x equals negative 50x squared plus 600x minus 100x plus 200 equals negative 50x squared plus 500x minus 200. And then with our graph, comparing the three representations, the equity function q of x is a quadratic function since its graph is a parabola. This is confirmed by the second differences in the table being constant when delta x is also constant. Therefore, its equation can be determined using patterns in the finite differences from the table, as well as by subtracting L of x from A of x. As seen in both the table and the graph, the Good Food Company's equity starts low, perhaps due to startup costs, but the worth of the company increases until the 5th month of the fiscal year. The decrease continues, and before the end of the fiscal year, the Good Food Company's equity is a negative value, meaning the company has more liabilities than assets, since equity is the difference between assets and liabilities.